Welcome back to the deep dive. We're diving into neural graph databases today, something I know a lot of you have been asking about. We're going deep into how AI is using the relationships in data to understand information. And lucky for us, we have an expert here to help break it all down.
Happy to be here.
All right, so before we get to the really complex stuff, let's start with the basics. What exactly are graph databases and why should we care about them?
Well, imagine a jigsaw puzzle, but it's not a picture. It represents all the information in the world.
Okay.
And each piece is a little bit of data, and how those pieces connect is how we get the bigger picture. That's essentially what a graph database is. It focuses on the connections, the relationships between the data points, to help us understand that whole puzzle.
So it's not just about the pieces, but how they fit together? Makes sense?
Yeah.
How is that different than the databases we're used to, like the ones that power our online shopping carts, for example?
Yeah, so traditional databases, they're more like spreadsheets. Neatly organized in rows and columns,
Yep.
very structured. And they're great for storing and retrieving individual facts, but they struggle when it comes to understanding the complex relationships. Think of a social network. You have people, connections, interests, all intertwined.
Yeah.
A graph database can map all of that out beautifully, showing how everything is connected.
I'm starting to see why this is important. It's like the difference between a list of ingredients and a recipe. The graph database shows you how to put it all together to make something meaningful.
Yeah.
Why is this so important, though? What can graph databases solve that the traditional ones can't?
Let's say you're trying to find the shortest route on a map. A traditional database can tell you about individual roads, how long they are, but a graph database that can analyze the entire network of roads and connections to find the most efficient path. And this power of relationships, this is really important in so many different areas. From analyzing social networks to understanding financial transactions to mapping out scientific knowledge, it's incredible.
Right. It's like having a GPS for data, guiding us through all that complex information. Okay, so we've got these powerful graph databases, but you mentioned neural networks earlier. How do those fit in?
That's where it gets really interesting. Think about our puzzle again. But this time, imagine some pieces are missing. Traditional databases might struggle to see the complete picture, but neural graph databases, or NGDBs, they can use AI to infer those missing connections.
Inferring those missing connections. Sounds like magic.
Not magic, just a very intelligent form of prediction based on patterns, like in a recommendation system. You like certain movies, and NGDB can analyze the connections between those movies, the actors, directors, and even other users' preferences. Then it recommends something new you might enjoy, even if it's not directly related to your previous choices.
Like having a friend who knows your taste in movies so well, they can suggest something you'd never thought of but end up loving. That's pretty cool. But before we get too lost in the AI weeds, can we see some real-world examples of NGDBs in action?
Absolutely. One area where we're seeing a big impact is with virtual assistants. They're moving beyond just questions and answers, becoming more conversational, understanding the context and nuances of what you're asking.
So instead of just spitting out facts, they can actually understand what you mean and hold a conversation.
Exactly. Imagine you ask your virtual assistant to plan a trip for you. An NGDB-powered assistant could analyze your preferences, your travel history, budget, even current events to suggest a personalized itinerary that takes all of those factors into account.
That's amazing. Not just asking for the weather anymore. Seems like NGDBs are taking virtual assistants to a whole new level. Any other applications?
Another really exciting area is fraud detection. Traditional systems, they rely on rules that can easily be bypassed. But NGDBs, they can analyze these complex networks of financial transactions to spot really subtle patterns that might indicate fraud.
So they're like digital detectives, sniffing out clues humans might miss. Fascinating. We've got a good idea of what NGDBs are and how powerful they are. Let's get into the nitty-gritty. How do they actually work?
Well, at the core of any NGDB, there are three main components: neural graph storage, a neural query engine, and a decoder.
Those sound pretty technical. Let's break those down one by one. First up, neural graph storage. What's going on there?
Think about it like this. Traditional databases, they store data in tables.
Uh-huh.
But with NGDBs, we use neural networks to create a flexible, multi-dimensional representation of the graph. It's like taking that puzzle and representing it in a way that captures all the connections and nuances, all in a way that AI can understand.
Multi-dimensional representation.
Yeah.
That sounds complex. Can you break that down a bit more? What's actually happening inside that neural network?
Imagine you're trying to explain a 3D model to someone who can only see in 2D. You need a way to capture all that 3D structure in a 2D format.
Right.
That's what's happening in neural graph storage. The network learns to represent the complex relationships in a way that preserves all the important information.
So it's like creating a blueprint of the knowledge graph that highlights all the key connections and patterns. Interesting. But once we have this encoded information, how do we actually ask questions and get answers? That's where the neural query engine comes in, right?
Exactly. The neural query engine, that's like the brains of the whole operation. It takes your question, translates it into something the AI can understand, and then uses that encoded graph to find the answer, like a super smart librarian that can navigate through a vast library of knowledge and pinpoint exactly what you're looking for.
That's a great analogy. Makes the whole process seem less intimidating. So the query engine finds the answers in this encoded graph. But how do we as humans make sense of it? The AI isn't going to give us a bunch of code, right?
Right, that's where the decoder comes in. It takes the AI's output, which is in this really complex encoded form, and it translates it back into something we can understand, plain English, or visualization, whatever is the most useful. It's like having a universal translator that can bridge the gap between the language of AI and humans.
Okay, I think it's starting to get the bigger picture here. Neural graph storage encodes the knowledge graph, the query engine searches through it, and then the decoder translates it back into something we can understand. It's like a well-coordinated team working together to unlock the secrets of data. But even the best teams have challenges, right? What are some of the limitations of NGDBs, or areas where they're still evolving?
Oh, you're absolutely right. One challenge is the sheer scale and complexity of real-world data. As datasets get larger, more interconnected, it gets really difficult to process and analyze them efficiently.
That makes sense. I mean, the internet alone is a giant, constantly evolving knowledge graph. How do NGDBs keep up with that kind of scale?
That's where a lot of the research is being focused, finding ways to make these systems more scalable and efficient. For example, there's a lot of work being done on optimizing the neural graph storage and the query engine to handle huge data sets without sacrificing accuracy or speed.
So it's like streamlining the workflow, making sure the team can handle even the most demanding projects. What other challenges are researchers tackling?
Another big area is improving the retrieval process, which is how the neural query engine searches through the encoded graph to find relevant information.
Retrieval.
Yeah.
Can you give us a little more context there? What makes it so challenging?
Think of it like searching for a specific book in a massive library. You need a way to efficiently find exactly what you're looking for. So with NGDBs, researchers are developing new algorithms and techniques to improve the speed and accuracy of this retrieval process, especially when you're dealing with complex questions and massive data sets.
So making sure the librarian can find the right book, even the most disorganized library. Important job. Anything else on the horizon for NGDBs?
Well, one really interesting area of research is exploring new ways to actually represent and query knowledge. Traditional approaches often rely on these symbolic systems where everything's defined by rigid rules.
Right, like defining every single connection and relationship manually sounds incredibly time-consuming.
Oh, it is. But NGDBs are starting to move beyond this, leveraging the power of neural networks to learn these more flexible and nuanced representations of knowledge. This is opening up a whole new world of possibilities for how we interact with and understand data.
Okay, I am officially hooked. We've gone from the basics of graph databases all the way to the inner workings of NGDBs, the challenges they face. It's been an incredible journey so far. I'm excited to see where we go next.
Me too. We're just getting started. Now that we've got a good understanding of how they work, let's explore some of those real-world applications in more detail.
Let's do it. I'm particularly curious about how they're being used in healthcare and scientific research.
Oh, excellent. Those are some of the most exciting areas where they're making a real difference. We'll dive into those and more in the next part of our deep dive.
Sounds great. We'll be back in just a moment to explore those fascinating case studies. Don't go anywhere.
Welcome back. You're curious about how these neural graph databases are actually being used in the real world. Let's start with healthcare. Such a ripe area for innovation.
Yeah. It feels like healthcare just has mountains of data, but connecting the dots is still a huge challenge.
Absolutely. Think about a patient's medical history. It's not just a list of symptoms and diagnoses.
Right.
It's a whole web of interconnected factors. Genetics, lifestyle, environmental exposures, previous treatments.
Wow.
An NGDB can analyze all of that to personalize treatment plans for doctors.
So it's like having a medical detective working to piece together all the clues to find the best course of action for each patient.
Yeah, great way to put it. And it's not just about individual patients either. You can analyze data from whole populations to identify patterns and risk factors for diseases.
That could revolutionize preventative care, right? Instead of waiting for people to get sick, We could identify those at risk and intervene early.
Exactly. And it even goes beyond prevention. Imagine accelerating drug discovery. Researchers can analyze tons of data on biological pathways, drug interactions, patient outcomes to identify new treatments.
That's amazing.
Yeah.
It really does feel like we're on the cusp of this new era in medicine where AI and data can help us solve some of the biggest health challenges.
Absolutely. Healthcare is just one example. Let's shift gears and talk about scientific research. Imagine if scientists could analyze the entire body of scientific literature, connect all these seemingly unrelated findings,
Yeah.
and uncover breakthroughs they might have missed.
Sounds like every scientist's dream. No more sifting through mountains of papers and data.
Exactly. NGDBs can create this knowledge map of all the scientific discoveries, highlighting connections and patterns that would be impossible for us to see.
So it's like having a super-powered research assistant that can just read and analyze every scientific paper ever published.
Yeah, this could lead to breakthroughs in fields like climate science, material science, even fundamental physics. We could really accelerate the pace of scientific discovery.
Mind-blowing. But all this power, there's a lot of responsibility that comes with it.
You're right.
We need to make sure these systems are used ethically and responsibly.
Absolutely. As with any technology this powerful, we have to be mindful of the implications. We need to make sure that the data is used responsibly, that we respect privacy, and we avoid bias.
So it's not just about building the technology, it's about establishing ethical guidelines and safeguards to make sure it's used for good.
Exactly.
Okay, we've covered healthcare, scientific research, two incredibly impactful areas. What other applications are out there?
Let's bring it back down to earth a little bit and talk about personalized recommendations. We see them every day. From movie suggestions to product recommendations.
Tell me about it.
Sometimes it feels like those algorithms know us better than we know ourselves.
Right.
Well, with NGDBs, those recommendations can get even better, more personalized and relevant. Imagine a shopping experience where the system not only understands what you've got in the past, but also your style preferences, your budget, even your current mood.
So it's like a personal shopper who knows everything about you and can suggest stuff you'll actually love, not just things you've bought before.
Exactly. And it can go beyond products. You could have personalized learning experiences, tailored news feeds, even customized travel itineraries.
Wow. Sounds like NGDBs could revolutionize how we interact with the digital world, making it more personalized and relevant to each person's needs.
Exactly. And this is just the beginning. As this technology keeps evolving, we can expect even more innovative and transformative applications to emerge.
This has been incredible. We've gone from graph database basics to how NGDBs work to these fascinating real-world applications. I'm feeling pretty inspired, but I'm curious about the future. What's next? What are researchers still trying to figure out?
Great question. One of the biggest challenges is making these systems more robust and reliable. They're still fairly new, and we're still learning how to design and implement them.
So it's like we've built this amazing new car, but we're still figuring out how to drive it.
Haha, that's a good analogy. Researchers are working on improving the accuracy, the efficiency, making them more resistant to errors and inconsistencies in data.
Makes sense. Don't want our AI making decisions on bad information.
Right. Another area of research is finding new ways to integrate NGDBs with other AI technologies like natural language processing, computer vision.
So making them even smarter, more versatile, being able to process information from different sources.
Yeah. Imagine a world where you could just talk to your NGDB using natural language, ask really complex questions, get insightful answers.
It would be like having a conversation with a super intelligent computer that can understand us.
Precisely. And that's just one example. The possibilities are really limitless when you start combining the power of NGDBs with other cutting-edge AI.
Okay, I'm really excited about the future of NGDBs now. Feels like we're on the verge of something transformative. But before we get too carried away, let's reflect on what we've learned so far.
Sounds good.
We started with understanding what graph databases are, why they're so good at analyzing those relationships in data. Then we got into how neural networks are used to create NGDBs. Systems that can fill in those missing connections and provide deeper insights.
We also saw how they're being used right now. Healthcare, scientific research, personalized recommendations, fraud detection.
And we talked about some of the challenges and opportunities that are ahead as researchers keep pushing boundaries with this technology.
It's been quite the journey.
It really has. But before we wrap up, I want to leave our listeners with a little something to think about.
I love it. Go for it.
What if we could use NGDBs to model and understand the entire internet with all of its complexity?
Now that's question.
Imagine mapping out the flow of information, how ideas spread, the connections between people and events across the entire digital world. What insights could we gain? What problems could we solve?
It's a tantalizing thought, and one that researchers are starting to explore. We might uncover hidden patterns of communication, understand how misinformation spreads, even predict new trends in culture and technology.
It's a future worth thinking about.
Yeah.
And with the power of NGDBs, it might be closer than we think.
Absolutely. NGDBs give us this powerful new lens to view and understand the world around us. And as we continue to develop them, it's important to remember it's not just about the data. It's about the insights, the connections, and the problems we can solve.
Well said. All right, everyone, that's a wrap for our deep dive into the world of neural graph databases. Hope you enjoyed the journey as much as we did.
It was a pleasure.
If you're feeling inspired to learn more, check out the show notes for links and resources.
And don't forget to share your thoughts on social media.
We love hearing from you. Until next time, keep exploring, keep questioning, and keep diving deep into the world of knowledge.
Until next time,
See you in the next deep dive.
welcome back to the final part of our deep dive into neural graph databases.
We've covered so much already, from graph database basics to the inner workings of NGDBs and all those amazing real-world applications.
It's been quite a journey.
Yeah. But before we wrap up, I want to go back to that question we asked earlier. What if we could use NGDBs to model and understand the entire internet with all its complexity? It's kind of a mind-blowing idea, and I'm curious to get your thoughts on it.
Well, it's definitely a challenge, daunting and exciting at the same time. I mean, the internet is this massive, ever-changing thing. Billions of nodes and connections constantly forming and dissolving. To try and capture that in an NGDB, that's a huge task.
Like trying to map the entire human brain with all its intricate networks and pathways.
Exactly, but think of the potential. We could trace the flow of information, identify key influencers, understand how ideas and trends spread.
We could gain insights into everything: consumer behavior, political movements, the spread of misinformation.
It'd be like having this real-time map of human thought and interaction.
That's powerful.
Of course, there are ethical considerations. We'd have to be really careful about privacy, data security, potential bias in the system.
A good reminder that with great power comes great responsibility, right?
Yeah.
We need to make sure these technologies are used for the right reasons and not for things like manipulation or control.
Absolutely. That's a conversation we need to have as a society as we continue to develop and use these powerful tools.
Well said. Okay, everyone, we've reached the end of our deep dive. I hope you've learned something new and gained a new appreciation for the power of neural graph databases.
It's a fascinating and rapidly evolving field.
Definitely. And if you're feeling inspired and want to learn more, check out the links and resources in the show notes.
And don't forget to share your thoughts and insights with us on social media.
We love hearing from you all. Until next time, keep exploring, keep questioning, and keep diving deep into the world of knowledge.
See you next time.
See you on the next deep dive.